let's make a burst.
Okay, hello everyone. My name is Cossas from NTHU, and today I'm going to talk about ALMA observation of FRB 121102. So first of all, what we need to understand what is FRB. FRB is a sudden brightening in radio frequency that only lasts for milliseconds. So a typical FRB shows up like this. The frequency range of FRB usually takes several million hertz, and the time that duration of FRB only takes several milliseconds. And there's two types of FRB. The first type is the non-repeating one. It is possible originates from the compact collisions, such like neutron mergers or neutron black hole mergers or black hole mergers. And the other type is repeating one. Repeating FRB is early in this year. A magna is accounting for the repeating FRB 200428 in the Milky Way. So there might be a lot more modules simulated by explaining what is FRB originate, but I'm not going to tell the detail here. So come back to our target. Our target suggests that it can generate up to 21 bursts within 1 hour. So there's a higher chance to use ALMA telescope to detect the FRB using the. Although the ALMA telescope has a larger time resolution, so and this figure shows the FRB 121102 band 3 ALMA detection. In this figure, the red circle indicate the whole galaxy of this FRB in the optical band using VLT, and the light green circle here is the possible origins from the FRB, and the darker green ellipse here is the secondary beam that indicates the PSF in this figure. From most recent active phase of this FRB, and with its periodicity of 157 days, we can find that FRB, our target, is under its activated phase during the ALMA observation. That means there's the higher chance that it likes to generate the burst in observation. So this one is the first day light curve. So you can see the red data point here is the flux density from the green ellipse in the figure previously, and the green data points here is the noise level, and you can see there is a slightly offset of the median of the data points from the FRB that can not be eliminated, and the second date is that we found that there's three peaks or detections of our FRB. The first one shows the signal to noise ratio equals to 3.06, and the figure shows like this. And the next one is the signal to noise ratio equals to 3.14, and the last one is equals to 3.22. So clearly these three peaks are barely above the 3 sigma criteria, but we still consider it as a detection. So in each data point in this light curve stand for 1 minute integration, because there might be as I said, the FRB can generate up to 21 bursts in one hour. So there might be multiple bursts in one integration. I mean, in 1 minute, the FRB can generate 2 or 3 peaks. So within this, ALMA can detect FRB. FRB ALMA might not be able to detect a single burst, but with a lot of bursts accumulated, then ALMA can detect it. So there we conclude 2 scenarios of this detection. One, first is the burst counterpart. Like I said, accumulated several bursts in each integration to form a detection in ALMA telescope. And if this is true, and we achieve a new highest frequency of about 92.5 GHz and 102.5 GHz, and the currently highest is only 8 GHz, is about 11 times larger than the currently highest frequency. And the second scenario is a host galaxy. All of these 3 detections show similar flux density of the FRB. So there might be the host galaxy characteristics of these 3 detections, but there's unable to eliminate offset of both observation. That means if we also exclude the offset from sky emission by taking other points from the background. And 3 sigma upper limit for host gas are also useful to rule out some modules. And here's my summary. This is important because this is for first time for ALMA to detect FRB, and it also shows the ALMA capability to detect FRB or host galaxies. And the high frequency FRB that detected by ALMA implies new orientation of FRB that can, or new physics. And we also suggest new method for detecting USB, not only using the F-fast or chime, but also can use by ALMA. And this is my talk. Thank you.
Okay, thank you, Cossas. Any question? Yes. So this is question from Albina. What advantages does ALMA have over other radio telescopes for FRB?
Actually, ALMA has compared to other radio telescopes, ALMA only has a higher sensitivity, and because the time resolution of ALMA is not quite well, but I suggest using the observe the repeating FRBs, so that can accumulate several bursts to form a detection in ALMA. Yes.
Spatial resolution is also better.
Yes. Sorry, spatial resolution is also better than others.
Yeah, there is another similar question. What makes it hard for ALMA to detect FRB?
Sorry.
What makes it hard?
Okay.
For ALMA to detect?
Because ALMA cannot, not like other radio telescope, it cannot separate the time resolution to milliseconds time scale. So it is hard to detect a burst of FRB.
Also, ALMA's field of view is small, so you need to know where exactly it is before pointing the telescope.
Yes. There is another question from Tiger. What is the SNR of this FRB by our telescope?
The other telescope, like VLA, is around 7, and lowest is at 7, and highest is of 50 50 signal to noise ratio.
Okay, thank you, Cossas. Yeah, it's time to finish. Because session should be finished in 12:45. So thank you, Cossas. Let's thank everyone for this session. So we would like to say again that our conference has been supported by Galaxy Journal. So let's have lunch.